Hello everyone, my name is Praveen Vanka and I'm a systems engineer here at Kasten. In this session, we'll review how to diagnose and troubleshoot common issues by leveraging existing resources. For more complex problems or the occasional bug, I'll show you pertinent information to capture for a thorough investigation and a follow-up by the Kasten support team. The best way to avoid running into problems is to validate the current environment. As such, it is critical to understand core tenets of a customer's Kubernetes environment and the infrastructure K10 is leveraging. Client details like kubectl and Helm versions, Kubernetes distribution, Kubernetes version, underlying storage systems are few such examples. K10 has direct integration with some of the more common storage systems, as well as CSI driver integration, as defined by the customer. So it is imperative that we understand the underlying storage infrastructure, whether that's block or file. A lot of the storage vendors are providing Kubernetes support via CSI drivers. They outline prerequisites to install these drivers, which are followed by a volume snapshot class object. K10 can leverage these drivers with a simple annotation that's specified in our documentation. What we notice sometimes is the volume snapshot class object has to be manually created, and customers miss this as part of the storage system or storage vendor documentation. Beyond cluster configuration, applications vary from each other and have various critical services. Understanding what Kubernetes artifacts are required for the application to run is important. In addition, it is good to understand what PVCs are associated to the application for persistent data capture. We need to ensure volumes are bound and determine which storage classes they're using. We understand there's a lot of information to capture and review, especially for each environment. To help organize and validate proper functionality, K10 has a pre-flight script which looks for compatibility details and prints out a report. Identifying and resolving any gaps prior to installing K10 would be the best way to start using it. Here's the sample output of our basic pre-flight script. As you can see, we're looking for several important items as mentioned previously. I'll review this in detail towards the end of our video in a demo walkthrough. The main goal here is to ensure that all of the operations come back with an OK. Now, beyond initial configuration and setup, there are a lot of moving parts when it comes to data management. As such, for a variety of reasons, there can be failures ranging from incompatibility to misconfiguration to infrastructure issues. Here's a list of the most common cases we might run into. Let's dig deeper into each topic. Deployment failures can be infrastructure related. Most of the time, we see issues when customers ignore the prerequisites or fail to read the documents. They go straight towards an install and realize that they run into an issue. They might run into a situation where K10 services or pods fail to come up, so they cannot access the dashboard. Or, in the event that they can load the dashboard, they'll still see continuous alerts notifying them of some issue. Failure during K10 install is usually indicative of a compatibility issue. It could be due to incorrect storage classes, where provisioners either don't support dynamic volume provisioning, snapshotting, or both. If a storage driver doesn't support dynamic volume provisioning, then K10 stateful workloads will be in a pending state because PVCs are pending, waiting for volumes to be provisioned. We've also seen issues with incorrect install options, and K10 fails to come up as a result. K10 is installed using the Helm chart with charts and images available in a public registry. However, installation can fail with image pool error due to clusters being air-gapped with no access to the outside world. This usually requires a customer to pre-populate their internal or private registry, which many don't realize ahead of time. Next set of failures could be due to misconfiguration or incompatibility. We've seen cases where K10 leverages native drivers in environments such as Ceph, VMware, Portworx, which require an infrastructure profile. And when that's not created, backups will fail. Similarly, when customers don't have compatible storage systems, K10 offers an alternative backup mechanism, which leverages our own data mover that copies data directly into the secondary target. This is defined by a location profile, and it can either be any S3 compliant storage or NFS. When location profile details are incorrect or missing, we've seen instances of failed backups. Because K10 allows snapshots to be exported to a secondary target location across the wire, there may be latency or bandwidth issues leading to job failures. If there are intermittent disconnects or service issues, then jobs can fail as well. Though not a common occurrence, due to continuous application development, certain resources in a particular application can be in a non-running state for a period of time. Now, this could be intentional because developers are continuing to build and develop the application. But to provide valid recovery points, K10 assumes all resources are in a running state. However, when resources are not in a running state, then a job fails. Now, there's an option to ignore non-running resources, but it has to be configured by the end user in a policy. Enabling this option by default is not recommended, and it's not a good practice. You may have heard of the phrase, it's not a matter of if, it's a matter of when. I believe this is applicable to any product regardless of its use. When something doesn't work, it'll help to identify the root cause. As with anything in life, most issues can be avoided with proper groundwork. Specifically, a lot of gaps in a customer's environment can be identified ahead of time by running our pre-flight scripts, as previously mentioned. There are two versions, the base version which captures pertinent information about the cluster and the environment, as well as provides a compatibility report. When using CSI drivers, we actually can go further and leverage a CSI-specific script, which invokes particular data protection operations that K10 will use and print out a status report for each test. Having run through these will set proper expectations, identify gaps ahead of time to reduce potential issues. Despite following all proper steps, when there is an error, K10 dashboard can be leveraged to narrow the scope. K10 has built-in alerts that will notify users when services are down or when a job or user action fails. While it provides basic details, more information is captured in logs. There are several areas in the dashboard that can be utilized to capture error details. Activity area to sort for failures, details pane to get the error stack, and policies or profile pages for specific issues related to those. In addition to these, K10 generates and collects a lot of metrics into our Prometheus service, which is part of the K10 application. Customers generally use their monitoring tools to scrape our Prometheus for pertinent config and build alerting and PagerDuty notifications and rules to follow up accordingly. Beyond the two options above, K10 collects pertinent logs for auditing as well as debugging purposes. We've documented commands to capture the full set of logs for better visibility into activity before, during, and after a failure. This, along with some details from above, will provide sufficient information for the customer or the Kasten support team to debug further. Here's a quick list of links for more details. I'll also go through them in our demo to walk you through the critical information. Here are a quick set of topics that we will look at in our demo. So now I will switch over to my terminal. As you can see on the left hand, I have a terminal window for my cluster. And you'll notice that it's a 3-node cluster and it's got K10 installed, and I'm exposing the K10 dashboard using this port forward command. Port forward is generally good for internal testing or quick testing in a POC. On the right-hand side is a browser. Right now I'm pointing to our Kasten documentation, which you can get by going to docs.kasten.io, and it will land us here. So I mentioned that the first step for any qualification running when you want to run K10 is to run our pre-flights. You'll notice that when it go to installing K10, our first and look at the requirements, one of the main areas that we highlight is our pre-flight check. So the simplest way to run this is copy and paste this into your terminal, and we'll go ahead and run it. Now I'll talk to some of the details that we're capturing here. As you can see, we look to see if we have the kubectl and Helm clients to be able to interact with our cluster. It'll look to see if the Kasten Helm repo has been configured on this machine so that we can go fetch the Helm charts and images that are required for proper K10 deployment. We'll also look for Helm version because with the older versions of Helm, there's a resource called Tiller that needs to be available. And what we'll do is we have basic K10 tools image with a bunch of tools to help diagnose and run checks for us. So we're actually downloading that image and spinning up the pod. Once the pod is ready, as indicated here, we'll go ahead and run some checks, right? So you'll notice we've got Kubernetes 118. At this point, I think that's a few versions old, but that's okay. We've got some of the features at a cluster level that have been defined, and we'll check to ensure that this cluster is CSI capable. Then we'll look at storage classes, specifically the provisioners in each storage class that's available, and then we'll make a determination against the CNCF defined valid providers to ensure whether it's a valid storage provisioner or not. Beyond that, we also look for annotations if it's a CSI storage class to see if that's available. If it's not already done, then we will report a failure here. And lastly, I talked about an alternative approach when there is infrastructure incompatibility, specifically with storage. We have a generic volume snapshot feature that we test to ensure that an application in such a scenario can still be protected. Lastly, all the resources we created earlier, we'll go ahead and clean ourselves up. So you'll notice that my cluster at a base level is good. I've got proper storage classes, so I'll know snapshotting and volume provisioning will not be an issue here. I've already got the dashboard loaded, so let's assume everything looks good. Customer installed the application K10 and they loaded the dashboard. Now, immediately you'll notice here, and you're probably already familiar with this dashboard, so I'll ignore the basics, but you'll notice compliance status, right? So there's a list of applications and the compliance status, and we'll know there's something that's not compliant. Just to simulate errors, I've misconfigured this application, but I just wanted to show you that under the activity pane, you'll see all jobs, whether that's backup, restore, exports, imports, etc. You can also filter by status, right, or by type, or by policy. So that'll give you better visibility into to narrow down. For now, I will go ahead and look at failed, and it will bring up all failed jobs. You'll notice times 3, every operation we retry 3 times because we understand sometimes there could be disconnects or intermittent hiccups that could occur, and we don't want to simply fail the very first hiccup that we run into. But more importantly, um, we don't, we don't see much information as to why this failed, but it does tell us to click here for more details. So we'll go ahead and click there, and you'll notice it opens a details pane. Specifically under phases, it will provide some information. To expand this better and further, you can click on Show Details, and it will actually print out a full error stack with the code and messages that make sense. So a lot of times this might not make sense to the end user or the customer, but having this information handy and being able to copy and paste that to our support team will help make the debugging process a lot faster. So you can do that. We can also look at why this failed, and that would be probably for different reasons. So you'll notice there are two failures, right? But this one succeeded. So in a backup phase, there are three phases, if you will. The first one is snapshotting the application config, which is successful. The second operation would be snapshotting the workloads, right? Whether that's deployment, stateful sets, etc. And then the last phase, which is snapshotting app components. This is the part where we're actually taking snapshots of volumes for data persistence. And together, all of these make for a good in-state application recovery point. If we take a look, again, similar to the previous example, you'll get more details as to what's happening. So here it says blueprint not found. And here we'll talk about, again, blueprint not found, right? So we understand what the issue is. When we set up or configure location profiles or infrastructure profiles, they're in settings. So we can always go to settings just to double check if a profile is still valid and in a proper working state. So what happens is sometimes we've seen where profiles are initially created, everything's working, and at some point in time, either if you're running a private object store, or especially for testing when customers are leveraging MinIO, sometimes those MinIO pods or services aren't running. Sometimes the IP changes because they were recreated, or for whatever reason, they may no longer be accessible. In such events, even though the profile was initially created, you will see a notification here that says there's an issue. Same thing with infrastructure profiles. You'll notice you can create one. And in a similar manner, if we have policies that were working and no longer are, especially due to profile incompatibility, we'll also get a notification that it's not a valid policy anymore. So these are some of the pieces of information that you can leverage the dashboard for. When K10 has some service that may no longer be running, right? We are notified with continuous alerts here. But another way to notice is you can append the URL with status, and it will take you to all of these services that are running behind the scenes. Right now, you'll see that my cluster is healthy and all of these services are running, but when they're not, it will be red and there will be an error message that has some additional details for you to see. Now, that's from a dashboard perspective. Coming back to the command line, I would like to show you a few more items. So I talked about there being a base pre-flight script. This is the base version. You'll notice that when we look at the storage provisioners, it's talking about it has identified a CSI provisioner, right? And we'll also know that that it is a CSI provisioner. So let's run a CSI specific pre-flight script just to show you what that looks like. So what I'm trying to show you here is I'm going to get the storage class. You'll know it's called DO block storage. And there's a provisioner here that was identified by the pre-flight script. What I'll also show you, as I mentioned earlier, every CSI storage class is or has a volume snapshot class object. Now, this is usually in the storage vendor documentation, but it's not, most of the time, it's not part of the storage class installation. So you would have to look through their docs for this particular uh, artifact to install. In this case, I've got a DO block storage volume snapshot class, which again leverages the same provisioner that the storage class is using. When we look at more details, so let's assume this is a new installation. I've got the storage class and the volume snapshot class. When we talk about leveraging CSI drivers, Kasten has the ability for us to leverage them, and we have a topic for storage integration. So when we go there, we'll highlight, the direct provider integrations as well as the CSI ones. And there are a few requirements here. Most notably, that this snapshot data source feature is enabled. With 1.14 or 1.15 version of Kubernetes, this is actually enabled by default, but it's always good to double check just to ensure that feature gate has been enabled. Here's the base primer, and here's actually the CSI primer. So we'll go ahead and take that, and -s is asking for the storage class name. So we'll go ahead and give it our CSI storage class name, and we'll run that. While it's running, I just want to point you quickly, one of the other requirements is for an annotation, specifically this annotation that tells K10 to go ahead and use this particular storage class or the volume snapshot class for data protection operations. We have an example here. You can either edit the YAML file and the resource directly, or you can use the kubectl annotate command to append the volume snapshot class. Coming back to this, similar to the other base primer, we'll make sure that the tools pod is ready and running. But what this does additionally is it actually double checks for specific operations. For example, it actually creates an application, a test application, and then it will take a snapshot of that application, and it will then go ahead, delete the application. We'll go ahead and then create a volume off of the snapshot and restore the application, including the data with sample data, and can come back with a report for the job. Here, you'll notice that this failed because it says permission issues, try again, run with user 1000. So I've run this previously, but really we'll just append the command above with these details. And we'll go ahead and run it. You'll notice that the pod got ready, and in this phase we are creating a test application. So in a minute or so, we should have that test app with the sample data created. And once that happens, we will go ahead and go through the next phase of the operation, which is now taking a snapshot. So keep in mind that when this test application is a stateful app, and that's why we have a PVC against it. All right, we've taken a snapshot, and we're restoring the application. And restoring the application involves creating a new volume off of the snapshot. And we need to ensure that volumes are bound, application components, the remaining app components are restored or created properly, and we'll restore the data and then consider the job successful. Okay, great. So we were able to restore successfully. And what this tells me is now I have the confidence that when I install K10 and when I run a backup job, an export job, an import or restore job, that using this storage class for my applications, that it will work without fail. So there's a lot of benefits that can arise from just running these two scripts, and it's pretty simple to run those, and we come back in just a few minutes. So that's always good. Now, we talked about dashboard, we talked about pre-flights. So another way to identify errors or look into some issues is to look at our logs. So I installed K10 in the Kasten namespace, but just to show you what we're running is we have a bunch of pods that are each responsible for specific actions that are running. You'll notice they're all running, and some of these have PVCs associated for persistence. For example, our catalog pod, which is the K10's database, will have a PVC associated. Prometheus, where we're collecting a lot of metrics, we'll want to make sure we store them, right, in case of server restarts or anything like that. Same thing with metering, logging, jobs. So these are pertinent, I guess, services to keep track of. When something is not in a non-running state, which is also shown here, right, in the status page, you'll see more details there. Similar to any, I guess, Kubernetes debugging and troubleshooting in general, when something doesn't work, we can always look at the describe of a pod. For example, let's pick catalog and just see what's going on. You'll get information here, and then there'll be events. If there are any issues, you'll see them under events. That's a quick way of diagnosing what's going on. Another option here is to actually get logs. Now, you can get logs from very specific pods that are responsible for those steps, or you can actually, what we have is a log aggregation service where we collect logs into the logging pod. And so what we can do is just say kubectl, get the namespace, logs, and then the pod name, right? And that'll give you a whole bunch of logs. Now, keep in mind, this is collecting logs from all of the services. That's why there's too many, right? And then we can also look for logs. Now, that is kind of some advanced troubleshooting. We don't expect all of our customers or users to kind of review and go through in detail. Most of the time, they just look at our dashboard and they'll, say, hey, we have a job that failed. Here's some details, right? And that's pretty much enough for us to start with. What we then ask for always, and it's good practice, is for debug logs, because debug logs gives us a full K10 capture and visibility into what's going on. So that is available here under operating and support and troubleshooting. We have additional details in this page, so I would advise you to go through our documentation. But I'd say the best command to run to capture debug logs is just this, right? Copy paste. And what it'll do is it will go into the namespace to run helm and kubectl commands and zip the file into into a compressed format for easier transferability. Sometimes we may need application information, specifically if we have, if we're looking at some particular application and we say, hey, K10 is failing in K10, and we don't really have good visibility into why something may be failing. And so if we take a look at our applications and we saw that MariaDB failed, I'll get the MariaDB application name. I think it's taking a while because it's running this. Interesting. Okay, there you go. Somehow lost connection there. So MariaDB. So what I'll do is just run this to get the information about volumes. A lot of times what we want to understand is K10 might say, hey, there's some volume bound issues or volume mounting issues, and that's all it will say. And we'll know the application name and the policy name, but we won't have more visibility. So running these commands will get us the proper visibility into the application and allow us to map things together. Once you have all of these information, you can always reach out to us via email or create if you're a paying customer, then you will have access to our support portal where tickets can be raised. I hope this was helpful. Thank you so much for your time.